Okay, we're rolling. We're back in the reactions packet for Friday. We are on page 1. Page 1 is not keyed, so I'm going to go through all 15 of these and we'll take it from there. First up, number 1, we've got copper plus oxygen making copper oxide. First thing we want to do is type it. Again, all typing goes back to our PowerPoint presentation. You have A plus B, make AB, or if you want to use colors, you could say red ball, blue ball, red ball, blue ball. That means it's a synthesis reaction. I'm going to do this even odd. There's an oxygen here. I'm even. Here, I'm odd. But I need to get even. To get even, I need to place a 2 there. So now I can go ahead and erase this odd. I've also now created a situation with copper that I'm even. Copper here I'm odd, but I need to get even. So I need to place a 2 in front of that copper. And now I can erase this odd. And it looks good. I'm even, even, even. Everything's even. I know it's done. On to the next one. Number 2. Again, you'll see the little subscript letters here, S, G, S, L, G, G. Just stands for phase. G is for gas phase. S is for solid. AQ means aqueous, it's in water. And you'll see L is liquid, that's also in water. It has nothing to do with the balancing or the typing. So first up, we got a reaction with a single reactant, and that's always a decomp. That's like 100 out of 100. Hit the free throws, do the easy stuff, bam, one reactant. That's all it can be. So I'm going to go even odd on this because here on this O2, I am even, and here I am odd, but I need to be even. So to get even here, I need to put a 2 out there, and that gets rid of that, and that oxygen now is even. Problem with hydrogen now is I have a multiple. I have 2 times 2, so I have 4 hydrogens. Remember, it's coefficient times subscript. So I've got a 2 here, so I put it there. I put a 2 here. 2 times 2 is 4. 4 equals 4, and the oxygen's even. That one's done and balanced. On to number 3. We have Fe plus H2O to H2 plus Fe3O3. So there's our reaction. Let's see what's going to be my strategy. First off, let's type it. Let's see, it looks like iron. Let's track the players. Iron's coming in, and it looks like it's kicking hydrogen out. Here, anytime you have a single player coming in and kicking something out, it's automatically a single replacement. So, let's continue on and start the balance. I'm going to start down here with this 3. I've got to make this oxygen 3. That's where I'm going to start. So I kind of like to start at the most complicated part of it, and that 3 just looked complicated. So I've got oxygen taken care of. The problem here is I've got 6 for hydrogen, so I've got to fix this. The number I need to make is 6, so 2 into 6 is going to give me 3, or I can reverse the cycle. 3 times 2 gives me 6. It's always coefficient times subscript. And then I think all I am left with is is fixing the iron. There's 3 of them there, so I need a 3 there, and we are balanced. That is indeed the 3rd one. Okay, on to number 4. Oh, this one looks complicated. All right. Ooh, we got a lot of stuff going on here. First, let's type it. It looks like we have cation, anion, cation, anion. When you have a cation, anion, anion combination, it's going to be a double. Okay, where do we want to start? I'm going to start with sulfur. I've got 3 sulfurs there, so I'm going to need 3 sulfurs here. That's going to fix the sulfur problem. I think my next stop is going to be hydrogen, because I'm sitting here with 1, but I'm going to have 6 on the table here. 3 times 2 gives me 6 for hydrogen, so I'm going to need 6 here. Pop that in there. And that gives me 6 chlorines. So if I have 6 chlorines there, changing up the color, I'm going to go with brown. 6 browns here for chlorine, so I need 6 chlorines there. Well, I'm going to reverse engineer this. 3 goes into 6. 2 times, or 2 times 3 gives me my needed 6. Coefficient times subscript. Okay. And let's take a look at arsenic. Arsenic, there's 2 of them here, and there's 2 of them there. I don't need to adjust that at all, and that one's balanced. Okay. On to number 5. Let's see what we got with number 5 here. We got copper sulfate pentahydrate. Making copper sulfate plus H2O. This looks unusual, and it is. It's called a dehydration reaction. All you're doing here is driving off the water. To do this, you just cook it in that oven down there. That oven right next to the fire extinguisher, that silver thing sitting on the counter. And swing this back. Okay. So this one's going to be easy to type. It's a single reactant, so its best fit is going to be a decomp. And then to balance this out, we got copper sulfate there, copper sulfate there. All we got to do is take this 5 and slide that 5 down there, and that one's done. Boy, I like those easy ones. Let's do number 6. All right, take a look at 6. Let's see here. We've got Fe2O3, H2, Fe, H2O. Okay. Let's start with a type. Let's see, let's track a player. When you're typing, pick one player and track it. I'm going to pick hydrogen. I'm going to see what hydrogen's doing. It looks like hydrogen's coming in and it's kicking iron out. So anytime you've got a single kick out there, that hydrogen's coming in and forcing iron out, that's going to be a single replacement. So let's get on to the task at hand, and that's going to be balancing this guy. So let's take a look. Where do we want to start? I'm going to start with that 3. I don't like 3s. I like leveling the 3s as quickly as possible. It's not a 3-2 scenario, so I've got to take that 3 from oxygen and make this oxygen a 3. The only way I can do that is put a 3 there. So we're going to go after hydrogen next. Coefficient times subscript 3 times 2 means that H is 6. So I need a 6 here to make an H. The only way I can do that is reverse engineer. 2 goes into 6 3 times, or 3 times 2 gives me 6. Coefficient times subscript. So the hydrogen's fixed. And then the easy knockout is iron. You have 2 here for the iron. So I'm going to need 2 here for the iron. I place that well-placed 2 there. Whammo, bammo, this thing is fried and dyed. Alrighty, let's do one more. Let's look at number 7. Calcium carbonate to calcium oxide to carbon dioxide. So hopefully typing now, you've got 5 types to choose from. There's the one type that has the single reactant in it, always, that's decomp. Single reactant, going to be decomp. So we're going to take a look at this. And let's see where we want to start. Ooh, we got a 3 there. I'm going to check my addition here first. I've got 3 oxygens here. I've got 1 here and 2 here. So 1 plus 2 equals 3. So my 3s are good. How am I on carbon? I've got 1 carbon here, and I've got 1 carbon here. Carbon is good, and the only element left is calcium, and I have 1 calcium here, and I have 1 calcium there. That reaction is balanced. There was no need to put coefficients anywhere. So this is going to conclude part 1, page 1, and we'll be on to page 2 next. Stay healthy.